working on week 4 test taking skills before we get started with the test, so please make sure you are on week 4 test taking skills. Number 1 says, Mr. Oliveira builds birdhouses and sells them. For each birdhouse, he uses 1/6 of a box of nails. If he has 3 boxes of nails, how many birdhouses can he build? Okay, so the question says, if he has 3 boxes of nails, how many birdhouses can he build? So we're talking about our birdhouses, so those are important, and also the nails. So anything with birdhouses and nails are important. So it says, for each birdhouse, he uses 1/6 of a box of nails. So he doesn't even use the whole box, right? Let's call this 1 box, right? And it says that he uses 1/6 of the box. So they're my 6, right? I know, but hold on, because I'm working with this right now. So there's 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. That equals 1 whole box. And it says for 1 birdhouse, he uses 1/6. So for every 1/6, he makes what? 1 birdhouse, 2 birdhouses, 3 birdhouses, 4, 5, 6. Everybody see that? So in a pictorial model, would it be easy to solve how many birdhouses he can make with 3 boxes of nails? With a pictorial model, it's very simple, right? How many of you have never thought to use a pictorial model? How many of you are now seeing like, oh, if I just draw a picture, that turns into a whole lot easier? Remember that I taught you, this is almost just like working with a conversion chart, a T-chart, because I know that 1 box now gives me how many birdhouses? Is equal to 6 birdhouses, right? Well, what do I know from the this is what I know from what I just solved, right? What do I know from my question? Do I know how many boxes or do I know how many birdhouses? What do I know from the question, Chris? Do I know how many boxes or how many birdhouses I have? Boxes. I have 3 boxes. Do I know how many birdhouses? Do I want to know how many birdhouses? Okay. How did I get from 1 to 3? So what I do to the left, I do to the right. So what is 6 times 3? 18 birdhouses. Now that's using a pictorial model, right? And did I have to draw all 3 boxes to solve that? No, draw it once and then do your conversion chart. If this is equal to this, then this is equal to this. It's an if-then statement. If you know this, then you should know this. Right? Alright, so as I was saying, take what you know and make a pictorial model. Use your pictorial model to make yourself a T-chart, a conversion chart. Right? We've seen these in measurement, but they can also be used. It's almost like, and it is like, actually it's not even almost like. I explained this during the week. It's an input-output. You go in with 1, you come out with 6. So you go in with 3, you come out with what? 18, right? Because if I go 1 times 6 is 6, 3 times 6 is? Because even if I go this way, how do I go from 1 to 6? How do I go from 3 to 18? So even if you do from top to bottom, left and right, or you do the top and then you do the bottom, either way it works. It's a conversion chart, it's an if-then chart, I call it an if-then statement. If 1 box is equal to 6 birdhouses, then 3 boxes is equal to 18 birdhouses. It's an if-then statement. It's called an argument in debate. If I know this, then I know this. Okay? Number 2. An author is writing a new book. She has a sheet of sticky tabs she uses to mark pages for her publisher to read and check. Each tab on the sheet is 1/3 inch wide and 2/5 inch long, as shown in the figure below. Here is a sheet of sticky tabs. All of this is one sheet of sticky tabs, right? And notice what they told us. Each tab on the sheet is 1/3 inch wide. So this is how wide the sheet is. And then it says, and 2/5 of an inch long. This is how long my sheet is. And the question wants to know, on the bottom right here is the question, what is the total area of the one sheet of sticky tabs? What is our mathematical keyword there? Area. Well, I remember when we learned area and perimeter, the area is equal to length times width. Do I have a length? Yes, I do. Do I have a width? Yes, I do. Do I know what my total length and my total width are? No, I don't. I know what my picture shows me, right? Okay, let's look at our picture really quick and let's determine what our length is and what our width is. So I have 1/3, 1/3, 1/3, 1/3, 1/3, 1/3. If I were to add all these up, okay, I would say 1, 2, 3, 4, 5, 6 thirds. Okay, 6/3. Well, when I say 6/3, that's an improper fraction, so I just tell myself, okay, 6 divided by 3 equals, that one's pretty easy. I don't have to do very much, do I? And remember what I've told you with an improper fraction, just extend your fraction line and make it into a division symbol. That'll remind you, 6 divided by 3 equals 2. So my width is 2. So right here, I'm going to come down and plug in a 2 under my W, because I know that my area is equal to something. Now my length, okay, 2, 4, 6. So my length is 6/5. So 5 divided into 6. Well, I know that 5 divided into 6 goes 1 time for sure, because 5 goes into 6 1 time, right? And I'm going to go ahead and do the work over here just so I have it. So I have my 1. There it is. And then I have 1/5. So my length is 1 and 1/5. So my problem then says I'm multiplying 1 and 1/5 times 2. How many of you are a little confused right now? Because we haven't worked with mixed numbers multiplying by whole numbers, have we? No. But here's what you do know. Okay, pay attention very closely because I want to explain how to do this for you. Okay, this is one way to do it. It's a very simple way. You're taking your whole numbers first. What is 2 times 1? 2, right? So take out this 1 because we're no longer using it. Now we're going to multiply 2 times 1/5. Well, the only way to do that is if I put the 2 over a 1. So I'm going to do that off to the side here. 2 over 1 times 1 over 5 equals 2/5. Because if I multiply, 2 times 1 is 2, 1 times 5 is 5, 2 and 2/5. So what is the total area of the sheet? It's 2 and 2/5 square inches, and that's actually square inches. Okay? Your answer would then be 2 2/5 square inches, H. And remember what I did say, and I didn't do it for number 1, but I just want to reiterate. Once you're positive of your answer, next to your number, just go ahead and put the letter, so that when you go back and bubble, it's pretty easy. Okay, let's go back to number 1 and do the same thing. Number 1, I was positive that it was C. Okay, so if I run into any that don't have an answer next to the number, what does that tell me to do? I have to double check it. I have to do it again so that way I can get an answer that I'm positive of, right? Okay, look at number 3. Number 3 says, let me move this over. A secretary had 6/10 of a package of paper to print some school forms. So did she have a whole package? No, she started out with part of a package, right? 6/10 of a package, more than half, right? Okay, because half would be what? 5/10. Okay, that's just extra thinking in there that sometimes you have to use. Because what if the question were to ask, did she have more or less than half of a package? Because sometimes it's that simple. Second sentence, she used all of the paper and printed attendance forms, grade sheets, and parent letters. So she used all of the 6/10 of paper. If she printed the same number of each form, well, how many forms were there? Attendance forms, grade sheets, and parent letters. Okay, so how many forms? Of each form, there are 3 forms, and I'm going to put that number right there so I have it. What fractional amount of the original package? Are we working with the number 6/10?
No.
We're working with 10/10, aren't we?
Yes.
Okay. Of paper did she use to print grade sheets? Are we wanting to know about parent letters and attendance forms? No, just grade sheets, but do we need to figure out all 3 of them? Yes, because they're all going to be equal. They all have an equal amount of paper. Alright, so in this case, I'm going to go ahead and draw my package of paper. And I'm just going to do it like this, okay? And I know that I have how many parts? 10 original parts. So I'm going to divide it in half, and then 2, 4, 6, 8, 10. I know it's a little off, but it's okay. Right? And it says that she started out with 6/10. But we are working with our original package. So here's 1, 2, 3, 4, 5, 6. This is how much paper she had to use, right? She used all of the paper and printed attendance forms, grade sheets, and parent letters. If she printed the same number of each form, what fractional amount of the original package of paper did she use to print the grade sheets? So, I'm taking my 6/10 of paper, right? Here's my 6/10 of the package of paper. And it says she used all of it to print how many different types of forms? 3 types of forms. There they are. So, I know I put a 1, right?
Yes.
It's division, right?
Yes.
Because I'm dividing the paper that's there by 3 different kinds of forms. I'm saying I'm using this much for form 1, this much for form 2, and this much for form 3. That is the same thing as saying I'm putting them into 3 different groups. So, keep, change, flip. I'm keeping 6/10. Did I do it? Yes. I'm changing division to multiplication. Yes, I did it. I'm flipping 3 over 1 to 1 over 3, and I did it. Multiply across. 6 over 1 is 6. 10 over 3 is 30. Okay? So now I have 6/30. But I take this, I can divide this by something. First off, this is what you always ask yourself. Does your numerator go into your denominator? 6 times something equal 30? 6 times what? So that means I'm going to divide it by the 6. Yes. Some of you are saying 5, 5, 5, because this is what you're thinking. 6 times 5, miss? No, but again, it is 6 times 5. That means that 6 is your greatest common factor. 6 goes into 6, and 6 also goes into 30. How many times does 6 go into 6? 1. How many times does 6 go into 30?
5.
So what is your answer? 1/5. 1/5. Anybody have any questions there on that one? Everybody good? Okay. Let's go ahead and get started with the test. We have 1 hour to get through 10 questions, so please follow along. We are on week 4, assessment page 1. This is where I am not figuring them out anymore. I am going through the problem, I am reading it, I am setting it up the way you should set it up, and then you are working it out. On some of them, I will not set it up with you. I will push pause. You will set it up. I will then unfreeze the screen and you will compare. Did you set it up the way I set it up? Okay? Number 1. An art teacher is molding plaster pumpkins for her students to paint in an art class. She pours 4/5 of a cup of plaster into each mold to dry. She has 5 pumpkins, or 5 pumpkin molds. How many cups of plaster will she need to make 12 pumpkins? An art teacher is molding plaster pumpkins for her students to paint in an art class. That is just informational. Here's where we start with what's important. She pours 4/5 of a cup of plaster into each mold to dry. So how much does each mold use?
4/5.
So, 1 mold uses 4/5 of a cup of what? Of plaster. This is my conversion chart. So for every 1 mold, I'm using 4/5 of a cup of plaster. It says she has 5 pumpkin molds. How many cups of plaster will she need to make 12 pumpkins? I will go ahead and read the question one more time, and you will determine what fills in the rest of your chart and what information you need, and if there are any distractors in your question. An art teacher is molding plaster pumpkins for her students to paint in an art class. She pours 4/5 of a cup of plaster into each mold to dry. She has 5 pumpkin molds. How many cups of plaster will she need to make 12 pumpkins? Alright, question number 2 says, a baker uses 7/8 cup of glaze on each dozen of donuts he makes. He shaded each model to represent the amount of glaze he used for 6 dozen donuts. How many cups of glaze did the baker use for 6 dozen donuts? Okay, in my pictorial model, I have, here's 1 dozen, 2 dozen, 3 dozen, 4 dozen, 5 dozen, 6 dozens. Here's the 6 dozens that he made. This is not the number of donuts. Please do not think this is the number of donuts, because if you look at this, it's not divided into 12, is it?
No.
Please do not make the mistake of thinking, this is 1 dozen, 2 dozen, yes, it's 1 dozen of donuts, but we're talking about the amount of glaze. And it says a baker uses 7/8 cup of glaze on each dozen. Okay, so my picture just represents the 6 dozens. It says 7/8 of a cup. Well, 1, 2, 3, 4, 5, 6, 7, 8. Well, isn't this showing me my 1/8 of a cup? And it's pretty much repeated across the board, right? It's repeated, 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 repeated. And it says he uses 7/8. Well, do I have 7/8 shaded?
Yes.
Yes, I do. So each one of these shows 7/8. And the question is asking, it says, he shaded each model to represent the amount of glaze. It even tells you, each model is the amount of glaze he used on 6 dozen donuts. And my question asks, how many cups of glaze did the baker use for the 6 dozens of donuts? So we want to know with how many cups of glaze did he use for 6 dozen donuts? Alright, we are now looking at number 3 on week 4 assessment, page 2. Number 3 says, Mr. Baker uses 3/4 of a gallon of paint to paint each section of his fence. How many sections of fence can Mr. Baker paint with the 9 gallons of paint? So my question is saying, he uses 3/4 of a gallon to paint each section. What does that mean? What does the word each mean? It means 1. To paint one section, he uses what? 3/4 of a gallon of paint. So for every 3/4 of a gallon, he can paint 1 section of fence. Right? It says, how many sections of fence? So obviously my question is here. Can Mr. Baker paint with 9 gallons of paint? So this is set up like this. Now here's the deal. If you don't know how to go from 3/4 to 9, you might want to go from 9 to 3/4. What is it that you need to do to solve either way of those? If you set it up, what is it that he's using? He is using 9 whole gallons of paint. And what is he doing with the 9 gallons of paint? He's painting sections, parts, pieces of his fence. And every time he paints a piece, it takes 3/4 of a gallon. So his gallons are slowly depleting. His gallons are slowly going down as he's using them. 3/4 of a gallon, he painted one section. 3/4 of a gallon, he painted another section. He has a total of 9 gallons of paint. How many sections of fence can Mr. Baker paint with his 9 gallons of paint? Alright, we are looking at number 4 now. Number 4 says, Franklin Street is 3/4 of a mile long. Is it an entire mile? No. There are 6 city blocks on Franklin Street. What fraction of a mile is each city block on Franklin Street? Again, Franklin Street is 3/4 of a mile long. Using a pictorial model, the whole street is how long? 3/4 of a mile long. And it says there are 6 city blocks on Franklin Street. What fraction of the mile, of the whole mile, is each city block on Franklin Street? Are we talking about the 3/4 of a mile? There are 6 city blocks on Franklin Street. So Franklin Street is 3/4 of a mile, and there's 6 city blocks there. What fraction of a mile is each city block on Franklin Street? Alright, boys and girls, on this question I want to clarify something for you. Where it says, what fraction of a mile is each city block on Franklin Street? Okay? Don't pay attention to that part. Pay attention to what fraction of the 3/4 of a mile is each city block. Okay? We're not working with the original mile. I need for you to understand that. Okay? This question is worded poorly. It should be Franklin Street is 3/4 of a mile long. There are 6 city blocks on Franklin Street. Okay? I want to know what fraction, and then this right here, take out of a mile. What fraction is each city block on Franklin Street? What fraction is each city block on Franklin Street? We're not working with the original mile because the question is not asking us about the 3/4 of a mile, and it should be asking what fraction of Franklin Street is each city block, okay, of just that street. And we know just that street is how long? 3/4 of a mile long. So you're taking your 3/4 of a mile and you're asking yourself, what fraction is each city block? And there are 6 city blocks on that street. Alright, moving on to number 5. Number 5 says, the weight of a bag of peanuts is 5/8 of a pound. If Laurie buys 7 bags of peanuts, how many pounds will she buy? In this question, it is asking, if the weight of a bag of peanuts is 5/8 of a pound. Right here where you have a bag, you're talking about 1 bag. So the weight of 1 bag of peanuts is 5/8 of a pound. You know how to set that up. 1 bag of peanuts is equal to 5/8 of a pound, right? If Laurie buys 7 bags of peanuts, how many pounds, we want to know about the pounds, will she buy in all? Alright, we are moving on to number 6. Number 6 says, Mrs. Prado bought 4 pizzas for her daughter's party. What do we have? 1, 2, 3, 4 whole pizzas, right? It says, the shaded part, we're only dealing with the gray part, of each model, of each one, represents the fractional amount of the pizza that was eaten. So that's the amount of pizza that was eaten. So in this first pizza, second pizza, third pizza, and fourth pizza, I'm going to count the slices. And I know that if I do one, I'm doing all of them, right? So they're identical pizzas. So I'm doing 1/8, 2/8, 3/8, 4/8, 5/8, 6/7, and 8/8. But how much of the pizza was eaten on each one? 5/8 of the pizzas. We have 4 pizzas and 5/8 of the pizzas were eaten on each one. Which best represents the total, you see the word total, amount of pizza eaten? Again, this question should take you no more than 2 to 3 minutes. Alright, we are now on week 4 assessment, page 4, number 7. Please make sure you are on page 4 and looking at number 7. Alright, number 7 says, a leaky faucet that drips 10 times each hour wastes 3/4 of a gallon of water a day. How many days, so we're looking at days, would it take for the leaky faucet to waste 18 gallons of water? Let me read this again. A leaky faucet that drips 10 times each hour wastes 3/4 of a gallon of water a day. How many days would it take for the leaky faucet to waste 18 gallons of water? Here's my question for you. And do not answer this out loud. We have some numerical information here that says a leaky faucet drips 10 times each hour, wastes 3/4 of a gallon of water a day. The question clearly says, how many days would it take for the leaky faucet to waste 18 gallons of water? That is the extent of the amount of work I am willing to do for you on this question. It is up to you to decide how to solve that. Again, this is not only a math test, it is a reading test. Can you read and can you determine what you're supposed to be doing in the question? Whether you're dividing or multiplying, and what information are you using for that? What information is the question asking you for? In this question, it is very clear what it is asking you about. I have even gone through and decomposed. I've broken it down for you. You should know by what you've heard and by what you've read yourself and by the strategies that I just showed you. What is it that you are doing in this question? Number 8. Which division problem is shown by the model below? Which division problem is shown by the model below? For number 8, keep in mind what the picture shows. I've explained all week long, when you see a model, pay attention to how the model is built. Are you working with several holes, one hole? Are you working with parts of a hole? What is it that you are doing? Alright, number 9. An expression is given. Expression is another word for working with a number sentence that uses parentheses, brackets, etc. Says, which statement about the parentheses is true in this expression? So we are looking for 1 true, and the 3 false are what we are crossing out. We're looking for the 1 true, and the 3 false is what we're getting rid of. And they're talking about the parentheses in the expression. Number 10. Marina recorded the amount of cups of flour she used in 12 different pies she baked. So in this question, she baked 12 different pies. Those are her 12 pies right here. These are fractions for the most part. Some are whole numbers. These are her 12 pies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And at the amount of the cups of flour she used in the 12 different pies. These are the 12 pies, and these are the cups of flour. So in other words, half a cup, 5/8 of a cup, 1/4 of a cup, 5/8 of a cup, 3/4 of a cup, 3/8 of a cup, 1 whole cup, 7/8 of a cup, 3/4 cup, 1/4 cup, half a cup, and then another 1 cup. Which dot plot represents, in other words, shows these measurements? So we're matching this to either F, to G, to H, or J. Which one of those matches the information in your data? Your data needs to be matched to one of these. Alright, on your week 4 assessment bubble sheet that came with your test, please make sure that you put your name up here, your first name, and your last name. No commas needed. Make sure you put a C or you put a D, one or the other. Cadena or Delgado, right here in this corner. Up at the top, go ahead and put the date. Today is February 17th, 2017. And next to each one of these, you are putting the little lines so that you can go in and fill in your answer choices. The way that's going to look is, if you remember in our work, we worked out test taking skills together, so I will go ahead and show you what that looks like for test taking skills. We have C, H, and B. That is what you're doing. Next to the number, to the right of the number. You then take your pencils and you color them in, please. After you've done that, make sure you color them in neatly. Because we are practicing both bubbling and writing neatly. Once that is done, go ahead and turn in your test. You do have until the remainder of time for class. Hopefully you do well.